Hi, welcome. I am Michelle and this is Make Sense of Math. I am so glad you are here today. Today we're going to talk about the volumes of cylinders and cones and my favorite way to teach them in middle school math. So just to preview this a little bit, where I am, we teach this in 8th grade math. We teach the volume of cylinder, cones, and spheres in 8th grade math. In 7th grade math, they learn about the volumes of prisms. And so I always make sure to teach the volume of prism as the area of the base times the height. And so when we jump to 8th grade math, volumes of cylinders is just the same. It's going to be the area of the base, which is a circle, times the height. And so students always have a really good knowledge of cylinders before I teach this. Now, so you can see these cool shapes that I have. These like figures, they're 3D, they are clear, and they have a side that's open, so you can fill them with this, or fill them with whatever. I had a set of these in my classroom, and I loved them, and I just bought a set so I could show you this cool activity. And if you don't have a set, I suppose you could look for shapes around your house that maybe would work, but they do need to follow these conditions. They need to have the same height, and they need to have the same diameter for these circle activities that we are doing today. So that is something that you need. So I am using a bowl of rice. You could, when I was in the classroom, I used popcorn kernels, and you could also use like dried beans. I think my first year I used water, which I wouldn't recommend. I think I was thinking it would be better because, you know, it's a liquid, but it's messy and it's transparent. So when you're throwing it into this, it wasn't like easy to see where it was. And I suppose you could like color it, but I would just recommend using rice or something that's not messy. I always had a conversation with my students that no, this isn't going to be absolutely perfect because we are using, you know, there's always going to be like that space between the kernels or the rice grains. And so it's not an exact volume, but it will be close enough for the activity and they will get it. So again, they always have a solid understanding of cylinder volume before we do this activity. I always start with cones, and you'll see why in a minute. And you can do this like, if you just have one set of these, you could like set up at stations and have them rotate stations and do it at that station. You could do it as a class activity. I would get the students involved actually doing the activity in front of the class to keep people engaged. If you have a bunch of sets, you could, you know, break it up into small groups. So you're going to start by asking your students, if I fill this with rice, how many of these do you think it will take to fill up the cylinder? And they will guess. And I put all the guesses up on the board, and then the students get super engaged because they want to know if they're right. So I fill up, or you can have a student do this, fill up the cone and dump it in the cylinder. Whoops. I spilled some. It wasn't enough to make a huge difference though. And I always shake it to help the rice settle a little bit. And it will, you know, kind of fill up the spaces a little bit. And then we do it again. And then students at this point will start changing their guesses. Then we put another one in. Shake it around. And do another one. We'll do one more. You can see this will probably be about it. Dump it in. Okay. And you can see that it's going to take 3 of these to fill up this. So this volume is 3 times the cone volume, or you could also say that the cone volume is 1/3 the volume of the cylinder, given that the heights and the diameters or the radiuses are the same. So we're going to use this information and the volume of the cylinder formula to derive the volume of a cone. Okay, so let's look at this here. We're going to write the volume of a cylinder is pi times r times pi r squared times h, right? And the volume of a cone is going to be 1/3 of that. So pi r squared h, and you can either times it by 1/3 or just divide by 3, right? So that is the volume of a cone. Now we're going to go on with this information and jump to hemispheres, okay? And you're going to ask them the same question. If I fill up this cone with rice, How many do you think it will take to fill up the hemisphere? And they all guess. And then we do it, or have a student do it. Fill it up. Fill it up and dump it in. And you can see that it's the same, right? So the volume of a cone is the same as the volume of a hemisphere, given that the diameters and the height, now the height's got to be the same. So you've got to like picture the height like this. And that's going to make a point in here in a minute. Let me flip it to this screen where it's clean. So we're going to write this out. We have the volume of a cone is pi r squared h divided by 3. Now let's derive the volume of a hemisphere from this, the formula for it. Now the height of this hemisphere is the same, if you notice, it's the same as the diameter of the shape. Now I'm going to write it, actually, if you look at the formula, it's in terms of radius. So instead of writing it in terms of diameter, I'm going to write it in terms of radius. So right here where this cone is, instead of height, I'm going to cross out height, and the height of my hemisphere is 2 times my radius, right? So I have pi times radius squared times 2 times my radius divided by 3. And if I just to rewrite that, to clean it up, that's going to be 2 pi r, and I have 3 radius there, so radius cubed divided by 3, right? So that is a formula for the volume of my hemisphere. 2/3 pi r cubed. And then to go through a sphere, most students will get that that's going to be double the volume. So for my sphere, just write it down here. So the sphere is going to be, instead of 2 pi r cubed divided by 3, it's going to be double that. So 4 pi r cubed all divided by 3. And this is the reason why I like doing this. So if you can like get students to remember to start with the formula for the volume of a prism, and that it's the area of the base times the height, they can like derive these if they can't memorize them. They can think of the area of a cylinder as pi r squared times the height. They can remember this activity, that it was 3 of them. So the cone is 1/3 the cylinder. The cylinder is the same as, the cone is the same as half a hemisphere, given the height. And then, you know, that's twice for the sphere. And it helps students to make sense of it. And I mean, if they can memorize it, like, that's great. Like, that's wonderful. We want that if they can. If not, here's a way for them to have an experience to remember and to derive the formulas from that. Now, I have these stations you could use if you wanted to help teach this. Or you can just even use these as like a class activity, just a place to write down their notes. It starts with the formula. It starts with the volume of a cone discovery. It is just the same activity we did, but they're just kind of writing down their thoughts. And I always start with discovery first, because that's where the learning takes place and that's where the foundations are built. And then we go on to application, both like real world application and then formula application of that. And then after the cones, we do the spheres, hemispheres. And we do discovery first. We learn that. Jump to the sphere application. And with like real world application, the sphere formula application. And then I like this really, lots of papers here. This cool activity where they find the composite volume of this shape. And yeah. Anyways, so I will put the link down in the description if you want these. Again, you don't have to use them. It's just, you know, easier because they're already done, but you can do what you want. So I hope that helps, and thank you.